Welcome and thanks for joining this guide to LLMOps in 2025, where we'll explore how organizations operationalize large language models safely and at scale. Over the next chapters, we'll cover the core concepts, unique challenges, practical lifecycle steps, tooling choices, and forward-looking trends that turn experimental models into reliable, business-ready systems. This chapter introduces the LLM revolution and explains why LLMOps has become essential. We'll look at how recent advances changed expectations for what AI can do, why productionizing language models demands new operational discipline, and how LLMOps provides the tooling and processes organizations need to deploy these models responsibly and reliably. December 2022 marked a watershed moment as consumer-facing chat interfaces made powerful language models visible to everyone. From writing assistants to customer chatbots and coding helpers, LLMs reshaped workflows overnight, but also revealed real production challenges. Building polished demos is easy, while creating robust, secure, production-ready applications remains hard. So what is LLMOps? Think of it as MLOps redesigned for massive language models, covering the full lifecycle from development to deployment and monitoring. It focuses on billion-parameter scale models, specialized operational practices, and the unique tooling needed to manage context windows, prompt strategies, and ongoing maintenance for LLM-powered systems. LLMs represent a paradigm shift compared with classical ML. Foundation models are pre-trained by a handful of institutions, then improved through fine-tuning and prompt engineering rather than training from scratch. This approach lowers barriers to entry but brings exponential increases in scale, compute needs, and operational complexity that organizations must address differently than traditional ML. The timeline helps put this evolution in context. Transformer breakthroughs like BERT in 2018 gave way to massive generative models in 2020 and consumer momentum in 2022, with multimodal capabilities in 2023 and 2025 emerging as a maturity point for enterprise LLMOps. This history explains why operational practices have accelerated so quickly. In this chapter, we'll examine the unique challenges that make LLMOps a distinct discipline. Unlike classical ML operations, LLMs introduce new failure modes, cost structures, and governance needs, so teams must adopt different workflows, tooling, and guardrails to ensure performance, safety, and compliance across production deployments. LLMOps appeared as real applications exploded across industries. Writing assistants, marketing generators, coding copilots, and 24/7 customer chatbots all became mainstream. That rapid adoption exposed operational hurdles like spiraling costs, latency and scaling issues, hallucinations, bias, and security or privacy concerns that traditional MLOps tools weren't designed to handle. The core operational challenges cluster around four areas: designing and managing complex prompts and long context windows to drive consistent behavior, establishing quality control to detect hallucinations and bias, controlling API and compute costs effectively, and ensuring compliance for sensitive data in regulated domains like healthcare and finance.
How does LLM ops differ from traditional ML ops? Traditional workflows focused on training models from scratch, feature engineering, and owned infrastructure, while modern LLM ops emphasizes prompt management systems, retrieval augmented generation, RLHF integration, context window optimization, and new consumption-based API models that change how teams build and deliver AI services.
Although workflows share common stages, LLMOps puts a different emphasis across the pipeline. Data collection is broader and includes retrieval corpora, model selection leans on foundation models and prompt strategies, fine-tuning may be limited or replaced by prompt engineering, deployment supports API-driven consumption, and monitoring must track safety, cost, and hallucinations in real time. Chapter 3 walks through the LLMOps lifecycle step by step so you can operationalize models from concept to production. We'll cover practical activities and decisions at each stage, explaining how to prepare data, choose and evaluate models, craft prompts, deploy and monitor systems, and maintain safety and compliance over time. Step 1 is data collection and preparation. LLMs need diverse, high-quality datasets for training and fine-tuning, along with rigorous data cleaning, annotation, and version control. Bringing domain experts into the loop ensures labeled data reflects real-world requirements, and solid metadata practices make future retraining and audits far more reliable. Step 2 covers model selection and development. Choose the foundation model that makes sense for your use case, balancing open source and proprietary options, and use established benchmarks and domain-specific tests to compare candidates. A key decision is whether to invest in fine-tuning or rely on prompt engineering to reach your performance and cost targets. Step 3 focuses on prompt engineering and retrieval augmented generation. Iterate on prompts to improve precision and consistency, ground responses with external knowledge bases to reduce hallucinations, and validate approaches with real user data. Practical RAG examples show how grounding models on proprietary documents yields more accurate, defensible outputs for critical applications. Step 4 covers deployment and integration. Build resilient infrastructure on cloud or on-prem platforms, optimize APIs for latency and cost, and embed models into chatbots, writing assistants, and developer tools. The goal is to balance performance, scalability, and reliability so applications meet user expectations under real workloads. Step 5 emphasizes monitoring and maintenance. Implement continuous oversight for accuracy, latency, and cost, detect and mitigate hallucinations before they reach users, and monitor outputs for bias or toxicity. Pair real-time alerts with ongoing retraining cycles and prompt tuning driven by user feedback to keep models aligned and performant. Step 6 addresses security and compliance. Prioritize data privacy and regulatory requirements like GDPR and CCPA, secure API keys and enforce role-based access, and maintain comprehensive audit trails. Embedding responsible AI practices throughout workflows helps prevent harm, ensures accountability, and protects sensitive data across production systems. The lifecycle is cyclical. Data prep, model selection, prompt engineering, deployment, monitoring, and security form an ongoing loop that drives continuous improvement. Treat the LLMOps lifecycle as an operational feedback system where metrics, user signals, and governance feed back into each stage to keep applications safe and effective. Chapter 4 explores the tooling and platforms that enable scalable LLMOps in practice. From prompt engineering frameworks to vector databases, observability tools, and managed deployment platforms, the right stack turns manual processes into repeatable pipelines that accelerate development while preserving safety and traceability. The LLMOps tooling landscape includes frameworks like LangChain and PromptLayer for prompt orchestration, vector databases such as Pinecone and Weaviate for RAG, observability tools that surface model drift and bias, and deployment platforms from cloud providers to simplify production rollouts. Choosing complementary tools is essential to reduce integration friction. The case study of a maturity model shows stages from ad hoc experimentation to fully optimized CI/CD. Initial ad hoc testing, defined processes with version control, managed automation with monitoring and pipelines, and finally optimized continuous improvement. Achieving maturity means harmonizing people, processes, and platforms to reliably deliver value from LLMs. Cost and performance optimization is both technical and strategic. Monitor token usage to control API spend, implement caching and model distillation to reduce latency and cost, and apply horizontal or vertical scaling based on workload patterns. With careful optimization, organizations can significantly reduce operational expenses while preserving performance. Chapter 5 looks ahead at the trends shaping LLMOps, where automation in prompt tuning and deployment increases. RLHF becomes a standard for alignment. Hybrid architectures blend open and proprietary models for cost and performance balance, and ethical AI tooling grows to address fairness, explainability, and bias mitigation across the stack. The rise of LLM as a service is democratizing access by offering turnkey APIs that eliminate infrastructure complexity. Leading platforms provide managed models and developer tooling that speed adoption, while enterprises must still evaluate trade-offs between control, cost, and safety when choosing hosted services versus self-hosted alternatives. Preparing for next-generation LLMOps means embracing multimodal models that process text, images, audio, and video, exploring federated learning to preserve privacy across data silos, and building transparent systems that are explainable and auditable. These capabilities will be essential for trusted, advanced applications that operate across diverse data domains. The future of AI operations will be defined by advanced operations centers orchestrating thousands of LLM instances globally, with real-time monitoring, automated optimization, and predictive maintenance. These centers will ensure peak reliability and performance while enabling teams to scale AI services securely and efficiently for enterprise users. To summarize, LLMOps is the backbone of AI's next wave because it enables scalable, reliable, and responsible deployment of language models. By combining operational discipline with the right technology, organizations can transform experimental models into production-grade systems that deliver measurable business value while maintaining trust and compliance. Thank you for reviewing this guide to LLMOps. If you have questions or want to explore next steps, we can dive deeper into tool selection, best practices for enterprise implementation, community resources, and industry case studies that illustrate how LLMOps turns potential into repeatable, production-ready outcomes. Let's continue the conversation.